Hello, everybody. Welcome to ACM, where Nick is going to give a workshop on how to Python. But before we get to that, I wanted to do a little general body meeting slides, because this is when ACM has their general body meetings also. So yeah. And so for those of you who don't know me, my name is Jeffrey. I'm the president of ACM. And if you like this workshop and are interested in attending more workshops like this, then there will be a form at the end of the presentation where you can give us your email and we'll add you to our Slack or our email alias. So, woo! So, for today, I just want to do a couple of announcements, let you guys know what we're planning on doing for the rest of the term, as well as let Nick do his Python workshop. So, which some of you guys might have noticed since we spammed the WPI pages. We have a new Facebook page. If you're interested in finding out about our events through that, just search up WPI ACM. You can join our group, or you can just like our page, and you should do it. That way we get popular. That'd be nice. You can join our Slack with the form at the end. So yeah, you'll get that at the end of the presentation. We also have a Relay for Life team. If you don't have a team and you need federal work study community service hours, you can join our team. If you stay for the whole event, you get 12 out of 15 hours, so that's a big plus. Other than that, if you just want to go to Relay for Life and you don't have a team, we're welcoming anyone to join our team. And if you're interested in helping ACM and the exec board plan any future events, we have meetings on Wednesdays at 4 p.m. at the CC 129. It's one of the conference rooms on the first floor of the CC. It's like behind the stairs. And yes, so this is what we have planned for the term. Today we're doing a Python workshop. It's here if you didn't know that. Next week we're having a Vim workshop. If you don't know what Vim is a powerful text editor which you can run within a command line terminal. You can do a lot of cool stuff with it. You should really come because I think Vim is the best. eBag sucks. And then the week after that we're doing a GDB workshop. For people who don't know what that is, GDB is just a debugger which helps debug C programs. And if you're taking the assembly course, by the time we get to this week, you'll probably be very dependent on GDB. So if you don't know how to use GDB, it'd be a good idea to come to that workshop. April 14th, it's going to be in a different room. We're doing a social to help de-stress for midterms. We're playing a game called Keep Talking and Nobody Explodes. So if you're interested in not blowing up, that'd be a good one to come to. April 11th, we're still deciding what we're going to do. Two potential things that we're going to have that day is we're going to have Staples have a representative come in and talk about their company, or we're going to have a discussion kind of thing going on where we have a video about some software engineering principles, and we would just have a general discussion about it. It'd be interesting. And then April 18th, we're planning on having a Selenium workshop, which is good for if you're ever planning on automating anything. And April 19th, near finals week, we're having a barbecue. So if you want free burgers and hot dogs, we'll be in the Fuller patio grilling up some burgers and hot dogs. And that's it for me. Nick, you can take over.
Great. Can everyone hear me okay? Okay, cool. My name's Nick. I should probably just go to my slides. That'd be important. All right. No, that is not what I wanted. You are what I wanted. All right. And can I... God, I can do it that way. Okay, so hi, I'm Nick. This is for Python, and I'm just going to skip the formality. First of all, thank you all for coming. I'm really glad that you all showed up. And so what I'm going to assume you know for this presentation is you're at least decently familiar with some programming paradigms that you, let me just get this up because this doesn't want to, there you go. Some programming paradigms, as much as I would love to, I can't teach basic programming in 2 hours, but this is more of a Python specific thing. If you know Java, I'm actually going to have a ton of examples that actually compare Python and Java in certain respects, so that should help you out if you already know the language. And they give questions. If you've ever had the displeasure of having a class with me, you know I ask a lot of questions, and I'm not going to say that you can't And certainly if you have questions, just raise your hand and we'll go with that. So why Python? Python is what we call an interpreted language. Something like C or Java is a compiled language because what happens is it gets compiled down to bytecode or machine code, very low-level code, and is run directly by the processor. I'm sure someone wants to correct me on some technicality in that, but that's more or less it. It's very extensible. If you can think of it, there's a module for it. Python is amazing for that. I've actually had times where I wanted to make QR codes, and I found a library in 2 seconds. Pandora has a library for it. There's everything. Python is very readable, and you'll kind of see that. You'll kind of see that as we go along. One of the key things about Python that you may notice: there's no curly braces, there's no semicolons, and the way that you actually handle blocks of codes is required by compilation indentation. Yes, indentation is required. So if you're ever writing bad code without indentation, now you have to write good code with indentation. Python is strongly and dynamically typed. If you don't know what that is, we'll get to in a second, but if you do, great, you'll think it's cool. And it is a truly object-oriented language. What that means is that literally everything is an object. Integers, objects. Strings, objects. Arrays, objects. Functions, objects. Objects, objects. And one of the best things about Python, in my opinion, is that it's almost like a playground. The Python interpreter. If you ever have any questions about Python, before you even have to Google it, if you can do something, you can just plop into the interpreter. So I can just do print hello world right here, and don't worry, I'm actually going to talk about it in a second, and it will work. You can just play with it. It's great, and it's great because you don't have to have a whole bunch of test.c or test.py files laying all around your system. So yeah, where did my presenter notes go? Did they just go away? Great. That is not helpful. All right, let's get to how that happens. All right. Might have to live with this title bar up here to prevent that from happening. All right. All right. Great. So, yeah, great thing about Python, everything's like pseudocode. Anyway, let's start. First, like any programming language, you just need your hello world program. In Python, it's really simple. All you have to do is do print hello world. You're good to go. Python or Java, I included a bunch of boilerplate just to prove a point that Java is a bunch of boilerplate. Just having a file with just print hello world with no main class or anything will absolutely work in Python. You don't need a class main whatever. And yes, it's just print in quotes hello world. One of the interesting things about Python that I just mentioned while we're on the topic. Single quotes and double quotes are interchangeable. There's no distinction between a character having single quotes or strings having double quotes. They're all the same thing. I just prefer double quotes, but the Python style guide says nothing about it. Actually, on that note, Python does have a style guide that people generally like you to adhere to. Something I actually went about through when I was writing these slides. I did everything in camel case, and that's actually not stylistically good, so I didn't do that anymore. But yeah, that's called PEP8, PEP8. If you really want to be writing Python seriously, you should at least read it once, or at least skim it. You don't have to read the whole thing. The other thing I just want to hit on is that this whole, sometimes you'll see this if you Google for something. That's actually an old version of Python, and for consistency, they actually made it a function. Don't use Python 2. It may look nice, but it's going to be stop supported in 2 years now. So don't use it. Don't learn it, because then you'll just be dependent on it, and then you won't have any new things, and you'll be sad. All right. Variables. Variables are super easy in Python. You don't even have to declare a type. You just say whatever you want is equal to something. So school is equal to my string, WPI. Great. Grad year is equal to 2021. Great. Free time is equal to half a second. Great. This is in stark contrast to Java, where I actually have to declare the type at the start there. And it's just a very nice little thing that you have there. Python is what we would call dynamically typed. Is that my example? Next slide, yeah. So that means that any variable can change to any other type at any point in the program. And Python is also strongly typed. And what this means is that we can't have, a type, in order to actually perform an operation, the types actually have to match what you're expecting. And I'll have an example of that in a second. So for instance, for typing, if I have error, Nick is trying to give a presentation, which is a very good error, and then I say error is 5, you can totally do that in Python. Java will yell at you. You can't do that. And it's kind of weird, but we'll get to it. Hang on. And to echo on that whole strongly typed thing. I included a JavaScript example because JavaScript is what we would call weakly typed. Python and Java are actually both strongly typed. So for example, in JavaScript, doing 5 plus foo will convert 5 to a string and make 5 foo. In Python, that will give you a type error, and you actually are going to have to convert that. We'll get to that in a sec. But you might be thinking, wait, if Java is strongly typed, I've totally done 5 plus foo in Java before. Why can I do that if it's strongly typed? Well, it's actually because under the hood, Java just does this whole thing where it actually turns into a string and then appends the strings, and it's all under the hood. And yeah, but don't use that as reasoning to think that Java isn't strongly typed. Types have to match for operations to take place. So you can't just do string plus number and expect it to work. Cool? Cool. So why would you want that? That just sounds dumb and great way to have programming errors. Well, one of the great things is if you have a function that might take a list or a number or a string and have it be different functionality based on that, you can do that. You don't have to write overloaded functions for all of that and do something like that. You can also have something like if you want to return from a function null versus if you wanted to return a number in different cases, you don't have to have a different type function to return different kinds of things. It'll actually, it's all built in and it'll take care of all of that. You'll see that a bit more clearly when I actually get the functions. So just some basic types: int, float, string, bool, whatever you think of. There's also this fun one, none type. Your null in Python is actually none, capital N-O-N-E. That's your null. So in Python, if you don't, none is actually its own type. So you couldn't do like none plus 5. That wouldn't work because it wouldn't be like C where it end up with 0 plus 5. It actually is its own distinct type. One thing that's a bit different than other languages, though, is true is actually represented by a capital T, true, versus false, and capital F, false. Just something to be aware of. There's actually some more types in this, but we'll get to them. Sorry, am I going a bit fast? I just want to make sure that I'm good. Good, cool. Type conversions. Long gone are the days where you must do string.value of whatever, whatever. Everything is super easy to convert in Python. So for instance, if I have a is equal to quote 5, I can just convert to an integer like that. Use str to get a string. Python is smart enough to where it won't try and convert hello to an integer. It will actually error out. Similarly, you can do the same thing for floats and booleans and all that. Cool. I know I'm going a bit fast. I have a lot I want to get through, but if anyone wants me to slow down at any point, just call me out on it. It's good. Python has a lot of operators that you might be aware of. The big one is that so your usual suspects: addition, subtraction, division. Then you have these weird ones like double star or double slash. That's kind of weird. So what you can so the difference is because Python, if you do 5 over 3, it'll actually give you the decimal representation as a float, and then it'll store that as a float type. And that might not always be desirable. So as you might know, so for example, if you're doing something like a binary search and you want to get the middle index, you don't want to. There's no 5.5 index in an 11-element list. So there is still integer division like you'd expect. You just have to do double slash. Modulo, list and string access. That's pretty simple. What else? We also have list and string access. Just like in Java, if you want to access an array, you can do. I'll get it in a sec. You can just do like array 1 or string 1, and you'll get the same thing. Yo, what's up here?
So does integer division round up?
Integer division rounds down. Did I do that wrong?
Then you made a map.
That is a typo on my part. That should be 5 over 3 is equal to 1. Thank you. I'll change that before I actually upload the slides. Yes, he rounds down, always.
I think your division also requires you to have floats to divide. If you divide with ints, it will give you an int as well.
No, it doesn't. And this is one of the great things about Python, because we can just verify these things in the.
That's true for Python 2.
Yes, Python 2, which machine? 5 over 3. Yep.
Yep, you're right.
Yep.
My bad.
No, you're good. Cool. So then taking user input, also something very important that you'll need in most courses. It's actually just pretty simple. All you have to do is just do input, and it'll take it in as a string, and then you can do whatever type conversions you need from there. So if you need integer, you can just do like int word like we had before. So like, yeah.
Sorry, I have a question about the previous slide.
Oh yeah, sure.
Is the list string access, is it start at 0, start at 1?
0.
Okay.
Yeah, like most real program languages, cough, not MATLAB, everything starts at 0. So like, so yeah, so if I did, I'll get to that in a second. And then with input, just as an example, let's say we do word is equal to input, or num is equal to input. Let's say enter 55. I can do int num, and I have my number. And num is actually a string, 55, as represented by the quotes here. Cool. Cool. All right. Oh yeah, also as a little bit of a shortcut, if you ever need to print a message for your input, you can actually just put it straight in your input function, and it actually will print it out beforehand, unlike having to have a separate print statement beforehand. It's just a little syntactical trick. It's kind of nice. Oh yeah. A little bit of fun fact, just before we move on to functions. Indexes can be negative. So name -1 will get the last character of your string, which is kind of weird, but it does work. Yeah.
Just a question on strings.
Yeah.
So are the wildcards, are the wildcards equivalent across C and Python?
Could you clarify what you mean by wildcards?
Well, like /n, stuff like that.
Oh yeah. Oh yes, they do generally share between Python. You mean the escape characters?
Yeah, escape characters.
Yeah, escape characters are shared. So /n is still /n, /t is still /t, etc. Yeah.
So if you can use negatives, does it throw an error if you try to do something bigger than the length of your string, or does it wrap around to the beginning?
That's a good question. Let's do something shorter. Average.
Okay.
Yeah, so it actually, I believe it will just go over to 0, so that should be, I think, 5. Yeah, that'll give me H, and anything bigger than that will error out. Yep.
This is a little meta, but what are we using here?
Oh, yeah. So this is, so normally the Python interpreter doesn't look like this. I just use this one because I like it a bit more. In your terminal, if you run Python 3, which is what you should be using, not Python, not actually give you Python 2. Python 3 will give you, this will just be your interpreter. I use something called IPython, which I prefer a bit more. That's just personal preference. It's the same thing, though, for all intents and purposes. That clear things up?
Yeah, can you just help me solve that later?
Yeah, sure. Why not? Actually, on Macs and all Linux systems, Python should be included by default. I believe Python 3 is now included on Macs. I'm not sure. You still only do Python 2. Anyway, cool. Oh, yeah.
So, would it be okay to use something like Eclipse for writing in Python, or would you recommend using it more of a text editor format?
So, well, you wouldn't want to use Eclipse because it doesn't have Python support. There are a bunch of Python IDEs. The one that comes with Python is called Idle. I don't really like it. No one really likes it, but it's there. The one that I've heard good things about is PyCharm, which is by the same people who make IntelliJ, if you ever use that. I personally just use Vim and the Python interpreter, but yeah, that's actually totally fine to use an IDE. It's personal preference. Cool. Cool, so everyone good before we move on to functions? Cool. All right, functions are pretty straightforward in Python. You just do def, and then your name, and then whatever you want as an indent. You have a colon on the end there, and this is actually equivalent to a hello world function in Java. That's really most of what it is. So if I were to go over to interpreter for a second, we do def, greetings, and then print hello world. And then we can just call our function like we would expect, it's just greetings. And that would just print hello world to the console. Cool. Yeah.
How does it know when the function ends?
It's not really clear in an editor, in the interpreter, but if I were to open, yes. If I were to open Vim, def hello world, it would be like down here. You see, because the indented block stops. It's required to indent.
So it's at the end of the indentation.
Yes, yeah, all blocks end at the end of indentation. Cool. As a more useful function, because most functions actually take parameters, you just put it. I realize now I have an error in the Java because you cannot just have typeless parameters like that. Whoops. Anyway, in Python, parameters are typeless, so I could very much pass in hello and world as my parameters. That is up to you as a programmer to not do. Python will error out if you try and pass strings into this function, because you can't exponentiate strings I wonder why. So yeah, this just gets us the power, num times exponent, and yeah, gets the exponent. And that will actually just return it as a variable, just like anything else you'd expect. So let's extend the power function for a second. Let's say that by default you always want the exponent to, you always want a square function by default. You can actually specify default parameters. Java does not have this feature, C++ does, but yeah, you can set default parameters. So running just pow5 like that will give me 25. Running 523 will give me this number that I don't know how to pronounce because it's very large and I don't really care about it. The only caveat with this is you can't overload functions in Python. So everyone knows what I mean by function overloading? Anyone not? Cool. So you can't overload functions. What you would generally have to do is you'd have to specify a bunch of parameters as like none or something and check if they're none to make sure they're calling the right one. That's kind of an annoyance, but it's a thing that Python does. Does he hand back there, or is that just... OK. Yep.
Okay, 2 questions. One, are there built-in functions or whatever to check what the type of a variable is currently?
Yes, I will get to that.
Okay, and can you nest functions?
Can you nest functions? Yes, you can very much define a function within a function. And one of the great things about that is because functions are objects, you can return functions. So you can just like make, I don't know, you make a function that takes it and takes an exponent and gives you a function that lets you return, that lets you always square the number. I don't know, whatever you want, you can do that. Yeah.
So you mean it's Racket 2.0?
I'm not going to answer that question. No, Python is not a functional language like Racket. But yes, you can do it just like you can in Racket. Oh, important thing. This is something you might know from C++ if you use C++, but if you haven't, all good. You can't have something like this where you'd have A, B is equal to 5, C. And the reason for that is because let's imagine that I called foo 5, 6, right? It wouldn't know whether I was specifying B or if I was specifying C. There's no way for it to know that. So what you can actually do if you ever run into something like this is you would put your other one up here and just deal with it that way. Cool? Cool. It's just a little gotcha. It's not something you'll likely run into until you actually like... One of the things about programming is I can tell you a bunch of these things and it might not make sense until you see it. But if you ever want me to show you an example, I totally can. That's just an important thing there. Cool. Mutability is a very important concept in Python. What mutability means is that if an object can change at runtime, it's really all it means. So like, I have an example, next slide. So for instance, there's this function ID that you'll probably never use, but it's just, I had it there just to show an example. If you ever program something like C++, it's almost like the memory address. It's just the ID of the variable. So for example, num apples is 20. If I print the ID of that, it's that thing. You'll see if I add 20 to it, it's actually a different ID now. So I've actually created a new variable by updating it. In a similar manner, strings are exactly the same. Strings are not mutable because you can't change them in place like that. And I haven't gotten to arrays yet, but I will in a minute. But this is just an example. Arrays are mutable in Python. So you'll notice that if I have numbers 1, 2, 3, and then I append to the numbers list, it's actually the same list. So what does this mean for you as writing your functions? Wait, sorry, do I see a hand? Nope. Yeah.
Sorry, thank you.
OK.
Can we just like go over the mutability thing again? I didn't get all that.
Yeah, sorry. Give me one. Actually, I think this example demonstrates it nicely. If you don't get it then I'll go back. So for instance, if we have add subject to our function, if I do greeting is equal to greeting plus world, and I print out the result, it's actually not going to have changed. On the other hand, if I do it with a list, which is a mutable type, appending to the list will actually mutate the one outside it. So all mutation is being able to actually change what the original variable is without creating a new one. Does that clear that up?
Yeah. So some things are mutable, some things aren't.
Correct.
I'm trying to wrap my head around which things are.
OK. Yeah, I actually didn't include a list because it wouldn't be comprehensive. But like things like integers, numbers, integers, strings, floats, things like that are all immutable. Things like lists and your own objects are all mutable. If you can change an object without making a new variable, it's considered mutable. That's a little bit of subtlety, but it does come in very important things when you deal like this, because you don't want to modify your string and expect it to change, but then you'll pass in an array and you'll see things like that change. Cool? Cool. Data structures. These are where we get to like the things like lists that I just said I'd get to in a second, but we'll get to them. So tuples or tuples, depending on who you ask. I think it's actually probably technically tuples, but I always said tuples, so I might just say tuples. Tuples are just ordered lists. That's it. You can't change them. You can't add anything to them. You can't change what's inside them. I don't care. They're just lists. No one, so if I just have x is equal to parenthesis 1, 2, 3, I can print x. And I can say that y is equal to the second element in my x. But I cannot change x to be x1 to be 5. That is a type error. You cannot do that with tuples. That's just a thing. But then, why would you ever want that? That just sounds dumb and counterintuitive. Well, the great thing is you can actually use this as a way to package values together. So, for instance, is everyone familiar here with like hex color codes? Anyone not? Okay, cool. Is that thumbs up and you're good or not? You're not familiar. Okay. So this takes a hex color code and gives us the red, green, and blue values of the color. Well, the nice thing about this is I can actually return these multiple values as just one tuple. So RGB will actually be equal to 201, 242, 132, because that's just the RGB of that color I passed in. But as a nice little bit of syntactic sugar, just to make your life easier, because Python is all syntactic sugar, and everything in Python is really beautiful and nice, you can do red, green, blue is equal to this, and red will actually be equal to 201, blue will be equal to 242, and green will equal to 132. That's just a nice little thing you can do. Good so far? Good? Yeah.
So is there probably getting a little too high level here, but is there a way to make a tuple of arbitrary length in a function?
As in, like, you append to it?
Well, you don't know how big it's going to be before you make it.
Yes, there is a way to do that, and I'll actually have an example in a much later example in this slide. But generally, you don't. No. You can convert a list to a tuple. That is a thing you can do, but not directly. You'll see. Lists. They're everything you ever wanted out of arrays. Dynamic size, sure. Multiple types in the same list. If you want to have a number and a string in the same list, I don't care. You can do that. Negative indexes. Yep, exactly just like strings. You can have negative indexes. By the way, that length function I showed before, len, like I did len of a string. I don't know if I touched on that, but I definitely put it in the slide. I might not have said it. If I do len hello, it'll give me the length. The same thing will actually apply to our lists, and the same function will do the same thing. So you can just get the length like that. So for instance, let's say I had my list of squares. That's not very many squares. There's a lot more than that. We can append the next square. We can print out that square, and we can get the length of squares. Cool? Cool. Oh, wait, was that a hand? No. Yeah.
Can you insert into the middle of the list?
You can. I don't know the syntax for it off the top of my head. I'd actually have to look that up, but you definitely can. I don't use it that often, so I just don't know it. And remember, just like before, lists are mutable. So if we do have our list that appends here, or we append to here, we can just do dot append 16 and everything works out. But we can't do that with a non-mutable type like strings. And that should answer what you were saying before about different types. This is one of those types. List slicing is one of my favorite features in Python that I use near religiously. What this actually allows us to do is just get a certain range of items. So let's say I wanted to get the third index on in my list. Actually, that's the fourth, but whatever. That will get the third onwards. If I want to go from the first item, which you could put the 0 there, but you can omit it. It does the same thing. It will get me the first 3 elements. 2 to 5 will get me 2 up to the 5th element. So not index 5. It's actually excluding the second one. And you can also use negatives in it. Just so it goes 2 to the second to last one, and you get 3, 4. As a little bit of a neat trick, you can actually assign to your slices. So you can do x up to the third and say 149 as my tuple, and it will actually mutate the list and put 149456. Yeah?
Can you assign something that's greater than or less than the size of the slice you're trying to take?
I don't believe so, no. I believe that will actually throw an error. So let's say we have L is equal to 1, 2, 3, and we have L is equal to this one element. Sorry. It's S. Yeah. Huh, I guess you can. Today I learned. I don't know why you do that. You can. I don't know why. Interesting. Huh, okay. I thought they'd throw an unpacking error. Yeah, because on a similar note, if you have a tuple 1, 2, and you do like A, B, C is equal to 1, 2, that will error out. But if we do, that will also error out. So I'm curious to why you could do that with slices, but not that. Interesting. Yeah.
Can you run up the end of the array?
As in, can you like that? Yeah, apparently. But I don't think you can start. Actually, you can start a negative index, yeah. What you can't do is do something like that'll just give you an empty list because there's nothing in that range. So important note is that list slicing makes what we would call a shallow copy of our objects. This is a bit small. I hope you can read that. But it doesn't actually make a duplicate. So for instance, if we have our slice. Yeah, so it makes a so that A does not change in this case because we assign the slice's first element to 5. That changes our slice, but does not change our list. But if we append to our slice, actually I got that explanation wrong. I'm sorry, that is my fault. Because numbers are not mutable, we cannot change the value of the number at a slice 0. But in our X slice, this is actually like a list of lists. I don't know if you can see that there. Because slices are mutable, because the list at the element is mutable, we can actually modify what's at that slice because it's made a copy of that list. And I think I butchered that a little bit there. But does that make sense? No? Yes? I'm going to go with no. Yeah?
Just a quick question. So for all intents and purposes, in the brackets, 0 and :1, they do the same thing?
Yes.
Okay.
Yeah. Well, actually, no. And the reason I say that is because slicing creates the copy there, or it creates the shallow copy. So if we do x slice 0.append to, we actually modify what's the first element of x. I don't have a laser pointer. It's the best I can do. So yeah, and I don't believe that indexing like that would do the same thing. That was a bit fast, but you got that? Cool. Dictionaries are also something you will see all the time in Python. Like if there's one thing you walk out of here remembering, it should be dictionaries, because you'll see them everywhere if you ever write Python code. Dictionaries are basically our key value store. So you ever done like a hash map in Java? That's this. So for instance, I have a list of all these people and their graduation years. I can print Binom's graduation year, 2018. I can add Jeff to the dictionary by doing graduation year is Jeff and doing 2019. And then I can print it out again. I get held back a year, so I set my graduation year a little bit higher. But I did not add Marianne's graduation year to the list, so that actually errors out. So you can't actually access elements that aren't there. You actually have to access ones that are there. Otherwise, it will get mad at you. But yeah, it's just a nice little syntax that makes these things nice. Cool? Cool. Conditional loops and iterables, these are all good things to just want to take as a stopping point. Are there any dangling questions, anything that I could be more clear on that you want? Yeah?
In terms of operators, are there bitwise operators?
There are bitwise operators, yes.
Okay.
Okay, anything else? No, okay. I don't know how to use caps. All right, so instead of covering if statements directly, I'm going to actually cover the conditionals you can use, and then that'll blend nicely into if statements. So for instance, equals equals, just like you'd expect, is our equality operator. And this is kind of the reverse from Java. We also actually have a second operator called is. And you'll think, well, if it's equal, it is the same thing. So like, why are there two operators? Only here's the distinction. Remember how I said that slicing creates a shallow copy? And it's not actually an identical thing. It's a copy of it. So if we make our slice here, x is equal to b because a slice will be equal to 1, 2, right? But x is not b. It has a copy of it. So it actually checks if they're literally the same object. X is x, but x is not b. Yeah?
So compared to C, is it the difference between comparing the value versus comparing the pointer?
Yes. And to compare it to Java, your equals equals operator is actually the same thing as is in Java, but your dot equals is the same as equals equals in Python. Yeah. A variable I didn't define. I meant a. I'll fix that. Thank you. Wow, I did not catch that one. Great. That was supposed to be a. Actually, no, sorry, that actually was supposed to be a slice. Oh, I know what happened. It was originally x, and then I changed it, and then I forgot. So yeah, so a slice. Let me make this more clear. Let me just do it on the slide because articulating is not going to be clear. What I meant was where are you? Where's my presenter view? There you go. All right. So yeah, that's what I meant. Does that make more sense? All right. Cool. Yeah.
Is quote 5 unquote equals equals integer 5 true or false?
So you mean?
Yeah.
But you can do. It's all good. I don't expect all this to stick, if I'm being honest. There's a lot to go through and a lot to talk about. So I can understand just forgetting little things about that. But yeah, conversions are super simple. You can also do, yeah, that'll work. Yeah.
Not sure if you went over this, but if there's no type checking in the parameters because you can't overload, then how would you type check?
I believe I have that in here. It actually might be later, but I'll just show you now. You can actually do, let's say a is equal to hello. I can do type A, and I get that. So I can do type A is equal to stir, true, but it's not equal to int.
Okay.
Yeah.
So what type is returned by type?
Type. That's actually an interesting, this is a bit of an aside, but because everything in Python is an object, just like Java, everything has to come from some object. Well, what object is that in Python? Type. And then objects are actually their own subclass of type, which is a little bit of a confusing distinction, but it is a thing and not something I fully understand or feel confidently giving you an explanation on, but don't worry about it. But yes, type, yeah.
So basically the function that returns the type is also just casting to the type.
Can you say that again?
So the function that returns the type of a variable is also just casting to the type.
Casting to the type. I guess it's not really casting, it's conversion. But I want to answer the question I thought you would ask, which isn't what it was, but that's also type.
So type is a type.
Type is a type is a type is a type is a type. I'm not going to keep going. So yeah. Oh yeah, also if you're ever checking for none, you can actually do x equal and none, and it might be very tempting. It's actually better practice to do x is none, because there's actually only one none in Python. Like if you set two things equal to none, they're actually pointing to the same address. And it's faster to check the address than to check the value. So it's considered better practice to do x is none rather than x equal to none. Cool? Cool. Conditional operators. These are all what you expect, but one of the cool things about Python, because Python is all about syntactic sugar, you can chain these together. So 5 less than 6 less than 8, true. 5 less than equal to 6 equal to 8, false. Can't, 6 is not equal to 8. So yeah, that's just a cool little thing. You can chain them together.
Which order does it evaluate in? Left and right? Precedence? Or?
I don't know. My guess is it just gives you the correct answer. Oh, sorry. Do you mean like, could you give an example where precedence would matter? And maybe I'll get into that.
Give me 30 seconds.
OK, yeah.
If you have like function calls.
Oh, I see what you mean. Well, because this is Python. Oh, I did that within the same function, didn't I? No, I didn't. OK, good. Oh, I did that within the function. No, I didn't. Yeah, it goes A, B, C. It's left to right.
Okay. And does it do short circuit evaluation, or does it always evaluate everything?
Yes. There's your short circuit. Everyone good? Okay. Yeah, Python is short circuit definitely with like your OR operator, which I'll get to in a second, or and whatever. But yeah, that's not. Yeah. Oh, there you go. Not or and. Great. There's exactly what you expect. Not is Java's bang operator. And is your and operator, or is your pipe operator. It's like what you expect. So x is less than 20 and x is greater than 3, false. X is less than 20 or x greater than 3, true. Or not of y is greater than or equal to 25 will give us the inverse because this expression is false. So that gives us true. All right, good? Cool. In is actually a really useful operator. Long gone are the days where you must linear search for your elements through your lists. You can just do 2 in x, and it will tell us it's true. And because Python is syntactically awesome. 5 not in x, that's actually the same as not 5 in x, but because Python is cool, it's a little bit easier to read 5 not in x than not 5 in x. So yeah, you can do that. It's a little cool feature. The important thing I just want to hit on with dictionaries is even though 2 is in my dictionary as a value, 2 in y will actually still give false. But a in y will give us true because it's actually looking at the keys set when I do the in operator. And I imagine some of you think, well, then how would I check if a value is? Can I just copy that easily? No. If I wanted, I can do d.values, I believe. Yeah, d.values, and I can do 2 in d.values, and it'll give me true. Cool? Cool. Yeah.
So I know it looks pretty, but does it still like take n things if there's n elements?
That's a good question, and I don't think it's defined by the spec, and different implementations of Python may do that differently. My gut says it's probably linear search. And they don't bother sorting because that would just be annoying. Yeah. And finally, we get to if statements. Now that we've gone through everything conditionals can do, well, almost everything. I don't want to say everything because there's probably something I forgot. All you got to do is you got to do if 5 in x, for instance, and it will do us that. Your else if is not else if, it's elif because, sorry. Sorry, I don't know what to tell you. But yeah, 2 in x or else it prints I give up. So yeah, if statements, just once you know conditionals, it all over real nice. Good? Yeah.
So noticing you put a space, sorry, not a space, but a new line underneath your if statements and then between the actual code. Is that just style or is that like necessary?
Could you, where? Here?
The space between
Oh,
yeah.
that's just Google Docs being bad. Google Docs likes to think I'm actually writing like text and not code. So there were a bunch of slides where I fixed it up for, but a bunch where I just didn't because it was inconsistent. I didn't always notice it. That new line is actually not a new line. That's actually just space after this line. There's no syntactual necessity for that. Just doing elif and then the next line being the indented line, that will work. While loops, exactly like you would expect. You have while your condition is true. And yeah, that's just that. You know, those are just while loops like any other language. Yeah. All right, for loops. I love for loops in Python. Yeah.
Do we have do whiles?
No. Do whiles. I don't. Someone correct me on this, but I don't believe any language other than C, C++ actually has do whiles. Java has do whiles?
Yeah.
Okay, no language other than those three. And now someone's going to tell me some esoteric language has them. Or maybe, what? We're not talking about that language. This is C-binding. Or I don't know. Whatever. There are no do whiles in Python. You'd actually have to have some kind of Boolean statement in there. You could probably do something like first run is equal to false, and if it's, you know, you just have a Boolean to flip that. If that's, you see what I mean? Yeah. All right. For loops in Python are actually awesome because they're all for each loops. So for string in strings gets us each string. It's just like the little colon loops. They're actually called in Java. They're just like your little colon loops in Java. They're actually all the same thing. But then your question is, well, if I have to deal with indexes, like there's some cases where you need to deal with them. Like that one right there, I'm squaring those numbers. Well, Python kind of sucks about that. I'm sorry. You actually have to write out all your indexes. No, I'm kidding. Don't actually do that. That'd be terrible. Python actually has a nice little thing called range. It will basically give us, well, a range from 0 to 10. Range is actually what we would call a lazy evaluator. This is an esoteric thing that if you don't understand, don't worry about it, but I can explain it if you want. Basically, it just doesn't, if we were to do range 10, it doesn't spend the computation time to create 10 elements. It actually does it one by one. Like it does, like tells us we're at the end of the range. But yeah, you don't really have to worry about that if you really want to program with it. It's just a little factoid. But yeah, for num in range 10 would do that. And you can actually, using our little type conversions, range is actually its own type, technically, because of what I just mentioned. But I can do list r, and we'll actually get a list of 0 to 10, or 0 to 9. So yeah, cool? Cool. Anyway, so for loops. Oh yeah, also another way you can just deal with indexes. Python has this nice little function called enumerate, which will actually give us our index and our value out. And we can just use both of them. So you don't have to sacrifice using indexes for your value. You actually get the little best of both worlds. It's a nice little tool you have. Does that make sense? Yeah. Oh.
Can you start range at an arbitrary value?
Yes, we can do. Oh. Yeah.
Okay, thanks.
Yeah. Jesse, you had a question?
Yeah, can you just like repeat enumerate? I didn't get any of that.
Oh, I'm sorry. Yeah, so enumerate actually might help with a little bit of example, but basically it actually gives us the index and the value. So like for instance, if I had L is equal to 1, 2, 3, if I do enumerate, if I do list enumerate L, if I spell it, it actually gives us tuples of each thing. Like these are the indexes, these are the values. Or yeah. So you can just use that little syntactic trick and just do index value in enumerate, and you'll get the index and the value out. Anything else?
So that'll always return tuples, doubles, right?
Yes, it will. Enumerate gives you tuples. Actually, it doesn't give you tuples if I do enumerate L. It's like range, and then it's a lazy evaluator. So it doesn't actually spend all the computation time to produce this first. It actually does it as you go. Cool? Cool. Oh, yeah.
Is there an enum type?
No. You would actually use dictionaries for that, likely. Worth noting, Python actually doesn't have constants. So yeah, there's that. Generally what you do is you just do like foo bar, like that. And that'll just be a little reminder to whatever programmer sees that should be constant. you shouldn't I mean, I can still change foobar if I really wanted to. But yeah, there are no constants. Sorry, it's a scripting language, but I should mention though, it's a very good scripting language. Reddit is written in Python. Anyway, yeah, what's up?
Can you have private variables as an object?
No, but I'll get to that. Objects I'm getting to towards the end. All right. Anything else? No? Okay. Oh yeah, loop control. You also have your famous continue and break. Do they cover continue here? I don't know. I've actually never... No? Yes? Everyone know what continue does?
Yeah.
Okay. No?
Justin doesn't know.
Justin doesn't know. Well, Justin, continue, what it'll actually do is instead of breaking the loop, it'll just skip everything after the continue statement.
Oh,
Yeah. Break will break your loop. So as an example of loop control, oh yeah, so another little loop control. Well, you see I have this loop here that while the input is greater than 0, it'll do, but I have this little else here. Else on a loop? What? Anyway, that will actually say if our loop breaks, it will not go to else. So it's actually like else is like my loop successfully ran without breaking. So like if I do, actually I might just duplicate this example. So we do here we'll do here's an example. So let's do while so I is equal to 0 while I is less than 50, or do 10. We'll do print I and then break, and then else print it didn't break. We'll get just 0 because the loop broke. But if I just comment out that line, oh, that I didn't actually increment I. But yeah, see, it didn't break, and I get my else statement to actually work. So else's they're actually really nice in Python loops. I actually don't use them that often, but I really like them when I can use them. So yeah, it's a cool little thing. That makes sense? Cool. List comprehensions are by far my favorite Python feature. I actually showed these slides to someone who wrote Haskell, and he was like, you love Haskell? And I'm like, no. Anyway, so don't worry about that. We can easily do this if we ever want to make a list of the first 500 squares. Squares.append I times I, the list is equal to Brett. No, that's gross. This is the same thing. Squares is equal to I times I for I in range 500 will give me the first 500 squares of the list. It's a really, really nice syntactic trick that's really helpful. Does that make sense? Cool. It's just a little nicety. And we can actually put little conditionals in there. So we only insert it if its cube is less than 100. So I get the squares of those first 4 numbers. Good? Cool. There are also dictionary comprehensions that do kind of the same thing. They're not really as useful, but they are there. You can do dictionary comprehensions. You can have your value there, and then your value here, and then your key here as a little comprehension there. Cool? Okay. Oh yeah, I forgot I had this. All right, so I'm going to attempt to do some live programming. Just as an, oh no, I did not want you to see that. It's live programming. I really just wanted a reference so I didn't have a bug that I couldn't figure out. Okay, so let's start. All right, so let's just start with some constants. We're gonna make I'm sure you've written things like this in Java before, but like a guessing game where you generate a random number and then you like pick from there. Yeah, like you guess what it guessed. Yeah, okay. So let's say we want the max guesses to be 5, and we want the default. And let's say we also want to. Part of what actually I wrote this guessing to be is like it'll also generate a random range. So I actually have a constant. To do the maximum. So actually, before I do that, let me just clarify what we're doing. So we'll generate a number between 1 and n. N is generated randomly, and then the number within that range is also generated randomly. So that's just a maximum what that higher bound could be. So we'll say our guess is equal to none. we'll say that the num guesses that have been done so far is 0. Actually, I really should be doing num guesses. It's better style, apparently. And then we'll work from there. So first thing we want to do is we want to generate our number. So first thing we have to do is we have to way to generate a random number. To do that, we're going to import random because you're importing the random library. So what you'll do is you'll do Jeff generate num. This is just my function to generate a number. And we'll say that the maximum is equal to that constant by default, but we can pass in whatever we want. So let's start. So to generate a random number, we can say that let's say our ceiling of our random number is going to be random.randint, which is it's just a function name. Use 0 to ceil max. Ceil max. I did that wrong. All right. Did I spell it wrong? Yeah. Great. Does it spell like? Yeah, it looks right. There we go. All right, and that will give me a random number between 0 and ceil max. Next, we'll have the number that we want to generate. So we'll say num is equal to random.randint 1 to ceil. Cool. Everyone like it so far? Good to go? Awesome. And then what we're going to do is we're just going to return num and ceil to whoever wants it. So we'll say that num and max num is equal to generate num like that. Cool. All right. So while our guess is not equal to num, which at first that will not happen because it's none. None is never going to equal to 0 because none is still type. So why guess does not equal num? And I have a typo there. Well, we would want to break the loop if they're out of guesses, right? So we do if num guesses is greater than our max guesses, and then we say print you're out of guesses. Sorry. And then we'll just break, right? Because you can do that. And then we'll say, we're going to ask the user for their guess. So guess input is equal to input, guess a number between 1 and I'll just add our little session. Don't ignore that error there. That's just a style thing that I have on. So we're going to say that our guess is equal to the int of the guess input, right? Because we have to convert, because you can't compare strings to numbers. And then we'll say that the num guesses so far plus equals 1. Great. So what we have so far is we just have a loop. We'll take in a guess and work from there. And then if we successfully make it through the loop and we have not broken, because it means they've guessed the number, we tell them they're right. Cool. Let's run this. Someone give me a number.
8, 4, 7, 6, 23.
But yeah, so let's say let's do 23. Why not? 23, 23, 20. Let's just exhaust all our guesses. You're out of guesses. Cool. Yo.
So on the top one, was the correct answer 6, or did you just get to the right number of guesses and it didn't break?
6 is the correct answer. It didn't break because the while loop exited before the break happened.
Where do you check that it's the right number?
Right there.
Oh, okay, good.
Yeah. All right. Yeah. Did I really? Well, now they can enter. Now they only enter 5. Live coding. Live coding. Anything else? Cool. All right. Let's close you out. All right. File I/O. This is probably the most boring thing in the entire. Why am I not? I'm gonna close that. Boring thing in the entire thing, but it's something that I heard you need for algorithms, so I did want to talk about it. You can just use the open function and you just open the path, and then the mode is equal to, like, you've done file I/O in Java, right? Anyone not? Okay. I'll take that as you all haven't. Basically, you open a file with a mode, so you only if you open a file for reading, you can't write to it. If you open a file for writing, you can't read to it. Whatever. These are all the modes that you could ever possibly need. Append. So the difference between append and write is that append actually won't clear the file before you write to it, but write will clear the file. X will only create a new file. It'll error out if you actually try to open an existing file. It's this little thing. You are not moving. There you go. These are all just a bunch of functions you could have. Really, I'm just listing these just for you guys to have. If you ever look at the slides, but I do want to talk about them. So file.read will give me however many bytes I ask for. File.read line will give me one line. File.read lines will give me all of the lines. File.seek will put my cursor at the nth position, and f.close will close the file. Always close your file. You can leak file descriptors, and you don't want that. If you don't know what that means, don't worry about it. Just always close your files. So just as an example of reading, we have our file here. Where's my cursor? Our file here. I read the entire file, and you can just see I have my file. I went back to the beginning of the file here, and I read the first 3 bytes in HEL, and then I did the rest of the file, or the rest of that one line, and it's just low because it's hello together. And then I go back to the beginning, and I get read lines, which will read all of the lines, and you can't see it because Google Docs decided to cover it for me, but I do close the file underneath this with just file.close, or a file.close, because I didn't do file because file is actually a type, and I didn't want to overwrite things. Like the reason I say that, and someone's going to hate me for saying this, I've just redefined integers. So I can do type 5 is equal to ints, and it'll return false. So that's why I didn't do file is equal to open. I actually did a file for that exact reason. So don't worry about it. Yeah. Are you happy with yourself, Connor? Yeah. Oh yeah. You can redefine everything because everything's an object.
Is there a button to like fix that?
Does that answer your question? I could do actually int. Now it's int again. I just wanted to let you know about that. Don't ever do that. Please, for the love of God, do not actually do that. But yes, you can redefine everything. I don't think you can redefine if, though. No, you can't. That'll yell at you. That's a syntactual feature. Okay. Writing is similar. I have my log file. I write to it, and I close it. Cool. Nothing more to say about that, but I can write to it. Yay. Also, I didn't include a Java example because the thing about Java is there's like 50 different ways to read files. I don't know all of them, and if I put one on here, someone's going to tell me I'm wrong. So I'm just not going to not be wrong by just not telling you that. Just a little thing I'd like to mention. I just had a couple things that I was like, I should probably mention those at some point in the presentation. I don't know why I never got to them. Here those are. Any is really cool. We can actually check if any element in an iterable, so like a list or a tuple, is true. So any of just a list of zeros will give us false because they're all zeros, so they're thus all false. And then if I add something to 1, there's one true element. So we say any L will give us true. Same thing, we can check if any of our squares are greater than 50 when we're doing the first 10 squares, and that'll give us true, because it's this little list comprehension that puts a Boolean of just the square itself being bigger than 50. Cool? Cool. Also type, we talked about that, and we abused it, and I'm sorry. Oh yeah, random. Random has a nice little thing called random.choice, which I really like. If you ever want to pick a random element, you can just do this. So like this will actually get me a random power of 2 between 1 and 10. It's kind of nice. Or 0 and 10, I should say, or 0 and 20 numbers. Time will give us the current system time in seconds since January 1st, 1970. If you don't know what that date is, that's the date that all Unix systems start from. for whatever reason, sorry. I actually won't talk about it explicitly because it's complicated and there are a lot of flags and bleh, but you can actually output dates, and I have a little link to the documentation. It's like Jan 5th, 2018 is completely possible to output if you want to. String formatting. You might have noticed throughout the entire presentation, I actually did something like foo plus bar, like with strings. Oh yeah.
Is time 32 or 64 bit?
It probably depends on your system.
Okay, just check. Oh yeah, but I'm just asking because if you like.
Yeah.
If like after 2038.
Yeah. I do believe that that's system dependent, and your system will automatically use 64-bit integers, but don't quote me on that. Let's see again. No. Cool. So yeah, string formatting. You might have noticed I did foo plus bar before. That's generally kind of bad because you're actually like creating two strings and then creating a third string, and that's like a lot, and that's nah. So what you actually should generally do is there's this nice thing called string formatting, where you can do like hello, and then you do two curly braces here, and you do dot format world. That will give me hello world. Yeah. I'm sorry, I failed you, Ben. There are curly braces now. I'm sorry. Yeah.
So whenever you create a reference, any variable or value just hangs around in memory forever?
No, it's garbage collected.
When? When it goes out of scope? Or?
Yes, when it goes out of scope, but I believe if you never reference it, the interpreter is smart enough to garbage collect it sooner. Yeah.
So obviously there's an advantage of using the dot format.
I'll get to that in 1 second, actually. Actually, one of the advantages right now, actually, is the next one I was going to talk about, is something like this. If you don't want to do like plus a, like a is equal to plus 5, plus 10, like every single time, you can use these little indexes, and you'll actually get the same thing by just passing 5 and 10 once. So that's one advantage. You can do more powerful things like that. Another important thing that I was kind of talking about is, let's say foo creates spends CPU time to create the string foo, right? Bar spends CPU time to create a string bar, and then the add operation will spend time to create a third string. And for some really big things that might get complicated, and format will actually optimize that a little bit. We can also do some more powerful things like doing named things like that, and we can also do like foo plus bar is equal to foo plus bar like that. In newer versions of Python, which I actually am going to have to go full screen for this, and so I hope this doesn't mess anything up. Great, it didn't even help me there. In newer versions of Python, 3.6 and up, which you might not use, but it's a cool thing to know about it, you can use little F strings, which actually will let you put Python expressions in these little braces, and it'll actually evaluate those and plop them into your string for you, which is pretty cool. You might not have access to that depending on what version of Python you're using, but it's a cool little thing. Yeah, you can do that. It's cool. There's a lot of things you can do like with string formatting. Like you can do like text alignment. So if you ever want to like always be right aligned, or you want there always to be 30 spaces before, or you want to like convert hexadecimal, like decimal to hexadecimal, it can do it all for you. I'm not going to go through all of them because there's too many. Like seriously, way too many. But there's some nice little documentation pages, and I really like pyformat.info because it will because it actually documents it quite succinctly. This is just an important thing I want to mention. You might, if you're ever like on Stack Overflow or something, you might see this syntax with like a % sign here. Don't use that. It's old and it's bad and it's probably going away. Dot format is the new way to do it. But the one plus side is if you're familiar with like printf style syntax, like in C, this actually uses that same syntax. But don't use it. You can. Please don't. I'm sorry. Okay, good stopping point. Any questions? No, we're good? Cool. All right, so classes. They're basically exactly like Java, except they're not. The couple of things to be aware of. Self is your this. I'm sorry, it is. Self is your this, but the only thing to be aware of is this. Like self doesn't actually always exist. It actually has to be a parameter to your function, and I'll show you an example of that in a minute. It'll be a bit clearer. Init you might hear this as like dunder init because there's 2 underscores there. You can't really tell it's 2, but it is 2. It's 2 underscores. Dunder init. Dunder is your constructor, and there are no private variables or functions at all. Everything in Python is public. Everything. But then you have those things where you don't want them to be public. So what you do is you put an underscore before them, and your programmer sees that, and they mess up. It's their own fault. You can't blame you for messing up your stuff. So yeah, don't worry about it. So as an example, I just have a little example of a color class. I kind of had to wrap it around. Do note, and I can't really show this here, this whole thing is actually still indented under the class block. I just couldn't show that because I had to fit it on a slide. So I have my init function. You'll notice that self is the first parameter here. So I do self.r is equal to r, self.g is equal to g, and self.b is equal to b, and self.hex. This is one of those format string things I was talking about. This just converts the number to hexadecimal. If you want to look at more of that, you can look at one of those 2 links that I posted before. But this is just an example of the time you can string formatting. So this is a CMYK conversion function. Don't worry about the math. That's just the math of converting RGB to CMYK. And then I actually, this is a little bit of a hack here, but this actually is almost a tuple comprehension, so to speak. It's just the syntax for it. I'm sorry, it's just the syntax. Yeah.
So I noticed that class color has the parentheses after that. Can you put parameters into the class?
Yes, that's actually, I was going to get to that in a second. That's actually where you would put subclasses. So like,
So subclasses have to be defined in the parent class?
No. So it would be like class RGB color would be like color, like that.
Oh, so you mean the superclass?
Sorry, did I say subclass?
Yeah, you did.
I'm sorry. I meant superclass. You would just put the superclass there. And then we have this little private function. The one thing I do want to call attention to is self is the first parameter. Python actually gets a little bit mad at you. Oh, great. This is going to mess up my presenter again. Oh, well. Python does get a little bit mad at you if you do like class A and then like def foo and then return. If I do A is equal to A, that's how you create an object. I do like a.foo, it'll get mad at me because it's like, wait, there's no arguments, but I was trying to pass in self and I couldn't do it. So there actually has to be a self in this parameter here. Okay, let's go back to presenter view. Who's looking at my slides?
So does that go for all functions inside a class?
Yes, all functions inside a class. There is a way to do static functions that I don't actually have any slides, and I kind of put it at my last things I didn't get to slide. I'm not sure if those need self. But if you want to, yeah. Another just important gotcha just to mention, if I just say R here instead of self.R, that will error out. You actually have to do self.R, like this.R in Java. You actually have to do that. You can't just do R. It won't work. Sorry. But yeah, that's an example of a class. And we would instantiate it with just color, because we took 3 parameters, R, G, and B. You color one, this is color I picked. And I can just access a member of it with blue.hex, and I can call a function with blue.getCMYK. That make sense? Everything good? Cool. Subclassing, talking about this briefly. I'm not going to go into it. You've seen this from Java. That's just subclassing. And the other thing is super is actually a function. I don't know why. It is. Super is a function, so you have to do super this. But then everything else works just like it would in Java. Cool? Cool. Okay. Anything else before I wrap all this up? Yep.
Hypothetically, if we had a homework assignment where the problem statement said to return something in underscore init underscore.
Can you do that?
No. That's why I'm asking this question. Yeah, okay. Just
That's an error. Yeah. Is this hypothetical not so hypothetical?
Yes. It's hypothetically knowledge start.
Hypothetically Mellow Stark, not hypothetically Heinemann? I'm sorry. I don't know what to tell you. I don't think you can do... Oh yeah, you can do that.
Nick, why don't you just redefine none?
Oh, there we go. Aww. Or you could tell her that, you know, this, you can't do that, yes?
Python 2.
You could do that. Do I have IPython 2 installed? No. One sec.
It works if you do. Wait, hang on. I think I'm wrong. Sorry. Sorry for getting your hopes up.
I mean, the next step is to redefine non-type.
Never mind. Rip.
Uh-huh.
One call.
Yeah.
Define the typewriter.
Try returning none.
One sec. Pass is, I actually didn't talk about it, but pass is like, it's just, basically, you know how like in Java, if you don't want to do anything, you just kind of do that? Pass is like, if you're required to have a block, you would just put pass. Like it just is like, I'm done. Don't worry about it. It's just a syntactical thing. But you can do that if you want. You could do def foo pass. It's allowed. That's what it does. It basically just says, it's a no-op, basically. Like it doesn't do anything. That's all it does. Yes, all it does is that it doesn't do anything, like me. Anyway, wrap up. So there's a lot that I didn't cover. Python is very extensive. There's a lot in the standard library. There's a lot in other people's libraries. I didn't cover package management, like that whole installation thing I did. Yeah, I didn't cover that. You can learn if you want. Tool's called pip. It's included in every Python installation, except for the default ones. I think I should have to install it separately. That's the point. I didn't talk about generators. Generators would allow you to do something like if you wanted to have a function that returned all the powers of 2. Yes, all of them. You can use a generator. List expansions are really cool. You can kind of like take you can kind of take a list and like pass them as parameters, or you can take a variable number of parameters. It's a cool little thing. Yield is how you do generators. Decorators are like ways of like returning functions, as objects, and then like having them be all fancy and cool and just don't worry about it. Static methods, static at properties, a cool little class thing. They're not going to talk about it. Multiple inheritance. Yes, Python does have multiple inheritance, like C++. I've never once used it, but you can use it. It's there. But everything good should be good stuff for at least algorithms and at least anything you might need to know if you just want to have a fun little Python project. Do you have any questions? No questions? Cool. Well, my email address is there if you do want it. I'll leave it up for a second if you want to write it down, or if you don't care, I don't really know. Whatever. Just a little thing. We do have this little survey I'd like you to all fill out, just as like what you thought about this talk.
Please fill it out.
Yeah, Jeffrey will be sad if you don't. And then Jeffrey being sad makes me sad. And then I'm sorry. Jeffrey, please don't be sad. Guys, don't make Jeffrey sad. Is it actually? Oh, come. It violates the terms of service? What? For a Google form?
Request a review.
No.
Okay, one sec. Yeah, that's exactly what I'm doing. Sec. Ben, everyone stop messaging me on Discord just to get it on the screen. You're not creative or funny. It is a little funny. Okay, let's. I'm sorry, the URL is going to be slightly longer now. Actually, I can do this. This won't violate the terms of service. An error occurred with that link.
No, use a link shadifier.
Link shadifier? That's a thing?
Yeah, it makes all links look more shady.
Oh, I just opened the inspector. Oops. Go away. Bye. Now you have a URL you can use. Capitals matter, by the way, with Bitly. I'm sorry. Who's putting messages on my screen? Beanam. Look at his website. It's great. Justin messaged me too. Wow. I am checking my Discord. Plus friend Justin. Okay. Great. All right. So how was all your days? Good?
I got it a bit better.
Ask because returning something in the instructor.
Let's go get some food down there.
In the Google Drive that I'll put there eventually. And
Oh no!
oh right, you need that.
Survey.
Do you want the survey?
Yeah.
Okay, I'll do it in a little.
Slash.
I don't know. I guess I can't play sound through HDMI. I'm sorry that you don't get the B-movie intro. Not for me. It's just like Pulse Audio is just like no. Yeah. Okay. Thank you. Connor, stop sending me memes. Thank you. Yeah. Oh, you're good. It's Python. All right, let's get back to slide one. No, Python's really simple, and the syntax is actually quite elegant in a lot of ways. The big thing is that all blocks are indented rather than with curly braces. Yeah, that's kind of the small bit I can give in like 2 sentences. The slides are going to be available, though, if you want to look through them. I'm just going to do that now, actually. Oh, yes, we did record it. Is the light even on? Is the light still on? Oh, yes, I'm still being recorded. Hello, ATC. Oh, they have a countdown timer, too. If anyone wants to say something incriminating in the next 38 minutes, now would not be the time.